Okay, we've done similar. How do we do similar like shapes like this?
They had the same ratio.
So we had the same ratio. So it's going to be the same thing for a ratio. We actually dealt with this before, that we are going to have 2 levels of ratio before. Now we're going to add a 3rd level. So the first level we call scale factor. Okay, that's the first level. And that's, the example for these would be like feet. So scale factor is going to be perimeter, or it's going to be side length. It's going to be just regular measurements that you can measure with a ruler. We went over before area factor, or the area. I call it area factor, but it's not really what it's called. We'll just go with it. And that's going to be squared, because areas are in feet squared. And then we're going to add a 3rd thing, which is the volume number, or the volume factor. Okay, I think what the book calls it is ratio. Okay, and we had a theorem that said that this is true, that the area ratio would be squared. So I'm going to kind of show you how these work. But first, I don't think you know how to do this, or you've forgotten, because in Algebra 1, we're literally supposed to teach you how to do cube root. But that's it. Not to use it, not to do anything with it, but just that it exists. So hopefully we know that like 64, square root of 64 is what? The reason is because 64 is 8 times 8, right? Okay, cube root, you should have been showed something. And so we'll see if you remember this. 8. Well, if square root is 2 things multiplied together to equal something, cube root would be 3 things. So 2 times 2 times 2 would equal 8. That's how cube work works. For our purposes, we're not going to do cube root by hand. Cube roots get really big, really crazy. That's one of the problems with volumes, is anytime you cube something, the numbers get really crazy, really big, quick. So this is how you do cube root with your calculator. Instead of using the square root, and let me see if I can get punched in really close. I probably shouldn't do it like that. Let me do it digitally. So I can maybe back off. Let's get it. And then we're going to try to light it up so we can see it. I hate the process. I got little glue or something there. That's awful. Terrible presentation. All right, so normally when you do a square root, you hit this button, right? Second, this button. And I get that, and I just do like square root of 64. I get an 8. Great. What we're going to do here is I'm going to do a cube root. So I'm going to type in a 3. Then I'm going to hit second, the button above it. See how it has an X in front? And this is going to give me a cube root. So cube root of 8 is going to equal. Okay, do we understand cube root again? That's all it is. We're going to have to use it. And that's why I'm going over this again, because anytime you deal with, let me back this off again. Anytime you deal with volumes, you're dealing with a cube. And there's 2 ways. You always have to do the opposite. So sometimes you're going to cube the number, and sometimes you're going to cube root the number. All right, I think we got our basics done. And so what we're going to look at is we're going to look at simple stuff first, and we're just going to keep going. Okay, let's look at these 2 shapes. And I'm just going to quickly draw some 3-dimensional shapes. Yay. That's a little pyramid. That's a smaller pyramid. Great. So I'm just going to say that this line is 60, and this line is going to be 20. Okay. We're going to determine if these are similar. This line is going to be, we'll call this line 50. And we'll call this line 15. All right, let's see if they're similar. So I'm going to set up ratios, because that's what similarity was, right? So 60 okay, and let me not that I have comments turned on, but I need to do this so people don't think that I don't know that. This is an equilateral triangle because it wouldn't work if it wasn't. This is an equilateral triangle. It wouldn't work if it doesn't. I would need more numbers, and I don't want you to do all that work. So 60, what number does 60 go with probably? 50, what number does 50 go with probably? Okay, let's see if those ratios are equal. Are they? Okay. So 60 over 20 is 3 over 1. 50 over 15 is what?
3.3.
Well,
10 over 3.
10 over 3. Are they similar? Not similar. They would have to be equal to be similar, right? Do we remember doing that with just regular shapes? Is this part different? Not really. Okay. Don't make that hard. So now I'm going to move on. It's going to get a little harder. I'm going to have two shapes. Okay. And I'm going to say the volume of the first shape is, let me pick some numbers. I can't just randomly write numbers because, well, that's not how it works. Unfortunately, these numbers get big quickly because when you're dealing with volume, you're dealing with cubic units. So this is the volume of shape 1. I'll call it S1 for short. And this is going to be the volume for the second shape. We're going to have to determine whether or not these are actually I'm not. These are similar. We're going to have to find the scale factor of these figures. Okay, remember we have three factors. We got the volume factor. We got the area factor. We got the scale factor. So basically I'm starting on this big level, this cube level, and I want to go down to the simple level. So this is how you're going to do that. Okay. First of all, I'm going to set up a ratio with these two. I'm going to start with this one and over this one. 512. Okay. That's the first thing. I don't like that. I'm going to try to simplify that because we want to have all of our ratios as simple as possible. If you don't make them simple, it makes the answer not correct some of the time. So I believe that this turns into 8 over 27, right? Yep. This gives me the volume factor. That is not what I want. I want the scale factor. How can we get from this level, the cube level, to the 1 level? What tool would we have to use? We would use the cube root tool to move it from level 3 to level 1. Probably that's why I went over cube root, right? All right, so this is how you do that. To move from level 3 to level 1, we're going to do cube root of 8 over cube root of 27. There's other ways you can enter this in your calculator. The other way to enter this is you can put the whole thing, this whole fraction, under a cube root. But you got to be careful. Of course, you already know what the cube root of 8 is, right? It's 2. How do we know that? Because we've done it 3 times. What do we think 27 is going to be?
3.
All right, that's my scale factor. 2, 3. Okay? Do we see that? That's the new stuff. Seriously, that's technically all that I'm adding new is this. We've already done from 1 and 2. We just did it several chapters ago. And you probably don't remember it because there's not much to it. Okay, let's go ahead and say I got shape 1 and shape 2. The surface area of this one is 256 units squared, and the surface area of this one is just 64 units squared. They are similar. I want the scale factor. Okay, again, we got the 3 levels. The first thing I need to do is create a ratio. The ratio would be 256 over 64. Or if it tells you to do something different. Simplify this. Put it on the level it's supposed to go on. Okay, 256 over 64, I think simplifies very nicely. It doesn't simplify to 4 because that's not a ratio. It simplifies to 4 over 1. Okay, if the 1 disappears, you need it. Okay, I'm at level 2. I don't want level 2, I want level 1. How do I get from level 2 to level 1? We're never going to divide. We're going to square root. Okay, so we're going to square root to get down. Okay, so this would be 4 over 1. Square root of 4 is 2. Square root of 1 is? So then that's my scale factor, 2 to 1. So far, so good? This we've done. We just haven't done it with 3-dimensional shapes. On the worksheet, I give you the actual shape. But does it really matter what the shape looks like? Yeah.
Would we be able to get to 3, like volume from?
You're basically that we're going to get there. And so I'll answer that. And the answer is yes and no. Yes, there's a way to do it. No, you don't know how to do it. Yes, you'll learn it in Algebra 2. In geometry, we'll do it a different way. We will always go back to 1 before we go anyplace else. The reason is because there is something called a fraction, and you can do problems like this. We don't have time to learn it, but you can do problems like this. 8 to the 3 halves. What this means is 8 to the 3rd power, and then take the square root. We're not going to do that. That is something they do in Algebra 2. It's not that bad, but again, if we just use our algebra skills that we know to do this, then it doesn't add too much. But once you go to these fractions, I never use these again. I don't. Other people might. I just start doing fractions every time because it's less writing. And it's easier to put in your calculator. Okay, let's move on to the next thing. All right. So basically what we're going to do here is I just want you to do this. Here's a scale factor. 3, 5. That's my scale. I want area. I want volume. Come up with the ratios for area and the ratios for volume. And you always start at the scale factor and branch out. So how would I go from level 1 to level 2? Square. Yeah, square. So 3 squared is? 5 squared is? Okay, now I'm going to go back to the scale factor. We always start here. How would I get to volume? Cubed. 3 cubed is? 27. We've already done that, so you can cheat and look. 5 cubed we haven't done yet.
125.
That's easy to put in the calculator, right? So this kind of shows our different, basically our different things. And again, it should make sense because, like, if I measured 3 inches, that's, a line that's 3 inches long. This would be a square that is 3 by 3. That's literally what it means. What's the area of it? 9. This is a cube that is 3 by 3 by 3. And so we just did problems like that. So 3 by 3 by 3. So that's why it's 27. Well, you measure in cubes at this level, you measure in squares at this level, and this level, you just measure with a ruler. All right? Now we get to the fun stuff that I like. Scale factor is 5/6 between these two shapes. The surface area of the big one, of the first one, not the big one, that would be the small one, right? Is 272. The volume is 832. I want the surface area of the second one. I want the volume of the second one. How would I do that? Well, first of all, you need all your numbers. So, first level, second level, third level. First level is 5/6. Great. What's second level? It's what? 25? 36. I don't know where you got 272, unless you're just reading this, which is not a ratio. It is a number. 3. We already did 5. What's 5 cubed? And what's 6?
216.
Okay, that's easy to get these levels, right? This is how you use a level. Well, I know what shape 1 is, the smaller shape. I don't know what shape 2 is. How would I do that? Well, this is how I do it. I use my area ratio, 25 over 36, and that is going to equal, well, which number does this go with, the smaller or the bigger? It goes with the smaller. It's the first one, right? 272. And I'm looking for the bigger shape, the bigger surface area. How do we work it out?
Cross multiply.
It's cross multiply, right? And this whole chapter, imagine how difficult it was when you didn't get to use a calculator, or how time consuming. It's not really difficult. I almost messed that up by writing the wrong number. So that is 9792. Okay, and then we're just going to divide that by what, 25?
Yeah.
And we are going to round this stuff, I think. Okay, that's what I got. That's not what I got. Not even close. Why did I write that? 391.68. Okay, so that's all you got to do with that. Did I get this number right? Let's make sure. Okay, I think on the worksheet I'm nicer to you than this, and I think they actually just work out. Okay, let's look at volume. Again, volume, we're going to use the volume ratio. So you're going to set up the same way, 125 over 216, and that is going to equal 832 over what? X. And you cross multiply. We don't have to work this one out just for time. But that's how you set that up. Okay, the last one I want to do is basically the hardest it gets. Let's just do, I'll make an easier one. Let's do this one. 5, the surface area of the first shape. This is the second shape. Surface area is 5 meters squared, sure. The volume is 9 meters squared. The surface area of the second shape is 245 meters squared. I should make it hard and do it in feet. Or ones in meters, ones in feet? No, just kidding. Not doing that. And the volume is, I don't know.
Wouldn't number 9 be cubed? The volume of 9?
If I did it correctly, it would. All right, first thing we need to do is come up with our various tools. Our ratios are scale factor. So I didn't really plan this out very well, so I'm just going to do it right here. 1, 2, 3. Okay, which one can we do? Can we find the scale factor right off the bat?
Yeah.
How?
Surface area.
Surface area is not scale factor. Surface area is going to be the area ratio. Right? This has to be the level 2. So let's find the level 2 first. Let's just do 5 over 245. Simplify it. Does it simplify? Yes. What does it simplify to? 149. All right, 149. All right, I need to go to scale factor because we already talked about this where unless I use fractional exponents, I have to go back to scale factor. I cannot go directly from here to here. Okay. If you were to do that, basically you would have to use this fraction, which is you'd have to use that as an exponent. But I'm not going to do that, so let's go from here to here. How do I get from level 2 to level 1? I use the square root. 1 over 49, square root, square root. 1 is 1, 49 is. Now I can go up to volume, right? 1 cubed. 1 cubed is 1. I like ones. 7 cubed is what? Okay. So now I have my volume ratio. And I'm trying to find volume, right? So I'm just going to set that up. 1, 3, 4. 3 is going to equal, well, what do you think 9 goes with? The 1 or the 343? How can you tell?
It goes with the 1.
The 9 is going to go with the smaller one, right?
Yeah.
The bigger one goes with the question mark. But I'm going to change the question mark to an X, right? And cross multiply. This one's an easy cross multiplication. X times 1 is X. 5 times 343 is
1,715.
meters cubed. Okay? This never feels good because you're not used to getting big numbers in math ever, right?
Yeah.
But when we use cubing things, the numbers get big quick. So that's it. I'll turn this off.